today's episode, I speak with William Davis. William is a senior computational scientist. He's got a PhD in earth sciences from UC Berkeley. And backstory is actually quite cool. He and his friend won a competition at Meta when they got invited to the launch party of the latest Llama model. So they wowed the audience, won the prize, and in today's session, he's going to show us the application they built. They're calling it Geo-LM, and essentially is about extracting information from geological documents and leveraging the LLM and Python to build a 3D geological model. So let's jump in and have a look. Okay, William, welcome to the show, man. I appreciate you coming on. I'm very excited to see what you have to show us. This is about
Course, yeah.
LLMs and geosciences. So tell us exactly what is it that you're going to share with us today.
Excellent. Yeah, no, thank you. I'm very excited to be here. Thanks for inviting me. So yeah, I'm going to be showing a geoscience LLM tool that me and a collaborator developed together. So the background for this was I was invited to the launch party of Meta's LLM model last year, which was Llama 4. So they released like a series of models. I think it was called like Maverick and Scout. And these were really foundation models because they were multimodal and they had a lot more context available than any other model that had been provided. So I went along and I was working with my friend there, and we were both geoscientists in our background, and we thought, no one in this room actually knows anything about earth sciences. Let's give them a show and show them what cool problems we have in earth sciences. So we came up with this idea to extract, like just very generally, extract knowledge from earth science documents. These could be like geology reports or whatever, and then do something fun, creative with it for downstream useful tasks. And so that's the high level of what we did. Everyone loved it at the competition. We actually ended up winning the prize for best use of API. And so it was a really incredible experience.
Fantastic. That sounds really exciting. And you're going to show us today exactly what you built in that competition, which won you the prize.
Sure, of
Excellent.
course.
Let's get to it. I'm excited.
So I can share my screen. So, okay. Okay, can you see it?
Yeah, we can see. Yeah, very clearly.
All right, so this is just like a title slide of what we made. We called it Geo-LM, Geo Language Model, combining Llama 4 and Geology. And my collaborator, Gain Bunvinich, is now working at Google on LLM summaries. So he's an expert, and it was great to work with him. So the sort of motivation for this is that we've got this global problem in critical minerals. By 2025, we're going to have to mine as much copper as almost has been mined in all of human history, and we really need to accelerate the speed that we're exploring and discovering and mining here. But I noticed that there's this huge bottleneck, which is, I call it the geo-knowledge bottleneck, where you have all of this information that's stored in like technical reports, diagrams, and things like that. And, typically people will manually search through these. And once you've got that data or that information in your head, that knowledge is siloed away in that person. If that person leaves the company, that knowledge is gone. So this really motivates like an automated, large-scale, extraction of geological knowledge. And I know that companies like SLB are doing similar things from some of their products. And this was a sort of fun and scrappy open source approach for me and my friends to take a go at it. So we made this product in this hackathon. We spent 24 hours working on it. And basically, the idea is that you take a load of geological reports, you extract the knowledge from it, from the text, and also the figures, and you encode all of that information in what we call a geology domain-specific language. And then once you have that DSL and other information, you can use it for downstream tasks like making 3D geological models or other things. And in this project here, we found that Llama 4 was absolutely the best because it has such a huge context window. You can put in an entire 400-page report in that, and it will just go through the whole thing incredibly quickly. So it was really a treat to work with.
Can I ask you, William,
Yeah.
compared to a RAG pipeline where you build your private knowledge base from these documents in your very first step that you have on the diagram, you're not aiming at creating a chat interface for the user to ask questions with answers coming from the knowledge base, but you're actually streamlining the generation of a geological model in the one step. This is not a geological model generated from the user prompts, or is it? Or it's a RAG in it's equivalent to a typical RAG in that sense?
So it's multiple things, and I think your question there is really good, and it brings up multiple points. Like, so first off, I really love RAG, retrieval augmented generation. I think it's so great for enabling you to do much more with the current context that you have. I think a system like what I have created here could be even accelerated even more with RAG. It's just that Llama 4 already has such a gigantic context window that you can do more without resorting to that. But yeah, RAG is on the horizon for this project. I'm definitely experimenting with how we can make that work.
Okay, so it's good to clarify. So this isn't a RAG, so there's no vector database here. So you're extracting all the information and you're storing it in a JSON format, I presume, something like that. And that builds your knowledge base, and then you just basically leverage the huge context window. And leverage the meta model capability.
Exactly.
That's it. But there's no RAG, so that there's a key distinction to be made
there. Yeah. So it's all about like how is that geological knowledge stored? And I think RAG could be a great complement to something like this, but the path that we took was this geology domain specific language. And I think there's been a lot of work in LLMs recently about constrained generation, where you have this sort of generative process, but the thing that you want it to generate is very specified, like, it's JSON, like you said, or maybe it's a new domain-specific language, like the one that we created for this project. It's actually a very hard thing to do. So there's a lot of sort of like constrained or unconstrained generative ways to do this. And we sort of took advantage of built-in constrained generation capabilities in the Llama 4 API. I think a lot of the other flagship models like OpenAI, Anthropic, they provide API capabilities for constrained generation, but it's difficult. Like, believe me, I've done a lot of projects now with LLMs, and generating DSL or generating sort of structured data, it's tricky for sure. So you're noticing a very key part here.
That's where the IP really is, and that how do you actually store all of that knowledge?
Yeah, exactly. And then once we have this knowledge stored, like you said, we have downstream tasks. In this one, we chose to generate 3D geological models. Really, there could be so many different things, I imagine, being used with the knowledge base that's generated. You could use it for planning. You could use it for risk analysis.
Absolutely.
You could talk to it, like you said. You could use it with a chat interface. The potential is endless, really.
Absolutely. Okay, let's jump to
it.
Yeah.
Okay, let's carry on. So yeah, just like a flow of how it works, we have these input mining reports. We use OCR and image extraction to make summaries, and then also like extracting out the images as well. And then all of that gets sort of fed in another API call to make this geology DSL. So this is the sort of kernel of the knowledge base that's being generated here. This is the hardest part by
What we
far.
were just talking about, yeah, for sure.
Yeah, yeah, yeah.
Just curious,
And
in that first step, did you find that OCR was better than using a vision model?
that's a really good question, actually. It's one thing that I've been wanting to experiment now with. I really think vision models are the way to go, because these images and captions are laid out in very deliberate places. And I think that that could be a much better tool for information extraction. So I haven't done that yet, but that is for sure on the horizon.
Right.
Good point. Good point. Yeah. So we have our knowledge base, our geology DSL, and then we actually start doing stuff with it. And in this project, we wanted to make 3D models to, show off to the people at Meta. And so we used a Python open source library called NumPy to create these 3D visualizations. And I'm going to show you more in the live demo in a moment. But it was sort of nice to sort of see all of these pieces come together.
I can imagine that room with full of non-geoscientist people.
Yeah, exactly.
Opening their eyes and these beautiful, colorful 3D models
Yeah,
coming out the
It
other
was great.
end. Yeah.
It was perfect. It was perfect.
Worthy of the prize for sure.
Yeah. So, I just wanted to say that the code base is all open source. And, we did some stuff there. And then, yeah, like I was saying, I talked about making these 3D geological models, but really, downstream tasks for this are potentially limitless. Like we could use this for mine planning, risk analysis, summary statistics, report generation. There are, so many applications here, and it's really fun to be on that leading edge of like, what are the possibilities here?
Just again, we're going to jump to it, but in this case, you went straight to generating the model without having to create a chat interface for the user to actually prompt about generating the model, right? So
Yeah,
there's
no
okay.
chat interface at the moment.
Yeah.
I think, on the future that could be a cool feature. So, maybe you could chat with the geology DSL and change things. Maybe you could chat with different parts of the summary and influence the generated model that way. But yeah, another great possibility.
Absolutely. And just
Yeah.
curious at this point, have you had any follow-up interest from any company, for example, or anyone wanting to
Yeah.
expand on what you guys built in the competition and take it to a production level for
Yes.
the workforce?
I've had contacts with 2 companies who are in the front running for AI in mining at the moment. I'm not sure I'm able to say exactly who it is, but people who raised a lot of money last year and the year before. So very exciting for where this goes.
Oh, fantastic. Yeah.
Yeah. Okay.
Great.
Do you
Well
want to
done.
see a demo?
Absolutely. Let's jump to it.
Okay. All right. Okay, so this is the sort of, the demo part. It's a little simplistic maybe, but I think it gets across the ideas of what we do. So this is my sort of workspace where I interface with all of the back end that I've designed for this. And so all of the back end is sort of a SQLite database. So very easy, very simple to run on your PC. The API talks to Llama 4. I'm working on supporting other APIs at the moment. And then all of this front end is written in byte, so it's very easy to use in the browser. So
Sorry,
you
William,
have.
could you just move that little chat window out of the way?
Oh yeah.
Yeah.
Okay, very good,
Yeah,
very
that's
good. So you have this interface here to like upload documents that you're interested in putting through this workflow, or you can see previous projects that you've worked on here. So, maybe let's have a look at one of these just to start off with. So on the left panel, you see a load of generated and like summarized text that has come from a document that I've previously uploaded. So you can, you can read this for yourself. This is a summarization that the LLM has provided. And then also in the background here, it's not immediately visible, but there are like images that it's taking information from.
right.
So this is the first step. And then in the second step, it generates this domain-specific language. So there are rules and grammar that this obeys. So for example, you have all of the units at the top that it's identified of, in this region here, in this document. And then after the rule, after the entities, it goes through different rules of like, the verbs, something has been deposited. So this first rock is something is happening to it, it's being deposited. And then, a second one happens, a third one. And then these rules can also have constraints or relations with them. Like, for example, there's an intrusive body here that happens after this one, but you don't know exactly where it is. So it's got a little bit of uncertainty built into it.
So I presume that because you know exactly what is going to be the end product, which is a 3D model, and to build a 3D model, you're using a Python library, you know what you need to generate to feed into that Python step. So you build your DSL precisely to extract from your knowledge base all those inputs required. The way you go about building your knowledge base is by knowing what exact final product you're going to generate. So that will change depending of what final product you're going to generate. So if it's not a 3D model, if it's something else, you will need to come back to this DSL step and redesign it.
Yeah, that will change for sure. So like for the DSL, I use Pydantic, which is really great for defining these rules and grammar. But I think this goes beyond LLMs for sure, just like data modeling in general. I remember there was that SLB product that you showed me, the knowledge graph one. Yes, that's it. Yeah. So that's, that's exactly along the same lines of like, this is ways of representing domain-specific knowledge in very specific rules, like entities, values, and relations between them. Yeah. So I did a lot of work at this startup called Relational AI, and this was what we were all about. And I did some similar things for seismic data. So I think that in combination with generative models is a really exciting place to be in.
Absolutely.
Yeah.
Did you have the chance to go a little bit deeper into what SLB have done? Did you get a sense as to whether it's pretty much the same, but obviously at scale,
Yeah, I mean, it's for sure they've got a lot of resources backing behind that. I think it looks like a really exciting tool. I think their sort of chat interface is very interesting. If like supposedly it can actually learn from your workflows. I think sort of learned generation is a very interesting place at the moment in generative AI. And then the other tool, the knowledge graph tool, of course, is I love knowledge graphs, so I'm sort of very interested to try that out for myself. And so we generated this DSL, And then pretty much every sort of step after this is no longer large language models. This is traditional old Python.
Yeah.
So it takes this geology DSL and then a few other sort of spatial bits of information that are sort of hidden behind the scenes here. It sort of picks out like dip angles and spatial coordinates and things. And it feeds it into GenPy, which is an open source geological modeling language, and generates all of these nice surfaces that you can see for our geology model. And so, we have these deposited layers at the top here. And then after that, things get a little bit more interesting, where we have these intrusive bodies and sort of complex interactions between them. So this is really cool to have as a visualization. I'm not suggesting this is the truth, but this is what I'm thinking is like a great starting point. You can take this model, you can take this model and extract it and then get out the conditioning points and then, start to, plot that across geophysical data, across sections. But to be able to go from this in a matter of seconds is really powerful.
Yes, I mean, this would be akin to vibe coding an app for a concept you have in your mind, and in a few minutes you have something that allows you to fine tune at that stage prior to going into a full modeling workflow.
Yes, exactly.
So yeah, it's incredibly valuable.
So maybe it would be helpful. I could run through the whole process end to end.
That would be fantastic. Let's do that.
Yeah. So let's go back here. I have a document that I prepared earlier.
Great.
For Bingham Canyon. There we go. So this is a report on the mine in Utah. And so nothing happens until you click process document. And I've got to really hope that I'm not going to be rate limited at the moment. Llama 4 tends to be pretty stable, but we'll see. We'll see. This is always like, the luck of the demo. Excellent. Okay, so the text summary has been generated.
We already with have Llama. Sorry, William, to interrupt, but you went with Llama obviously in the context of this competition at Meta. But and you did mention the humongous context window that they allow. But have you tried alternative models?
No, not yet. It's something that I'm really keen to explore.
Right.
Yeah. I mean, I think benchmarking is really important, and Llama 4 has been really great so far, but I've been particularly impressed with the models that Google's coming out with at the moment. So I'm very keen to try that out.
Did you run into many issues trying to I'm thinking when I had a play with RAG pipelines, sometimes it was difficult to anchor the right vector for the answer you wanted because it was kind of conflicting information and the language used in the document was really it had an effect on that similarity search you did with those vectors. So I wonder whether it's pretty straightforward when you find the parameter value or name you need to fit into your 3D model construction step. But if it's not found or it's found in multiple places or maybe a little bit confusing, did you run into too many of those type of issues?
Yes, particularly at the GenPy generation step. And GenPy has this feature, I'll call it, that if it finds conflicting values with that, it will just refuse to generate a geology model.
Right.
So under the hood there is quite a lot of pruning of conflicting values. And for sure, that's something to investigate in the future of like, let's do some uncertainty analysis of like which ones are more reputable or valid and which ones are possibly, spurious outliers.
Right.
Okay. Yeah.
Okay, so we got our document uploaded. With the hit of a button, and a few seconds later, everything has been processed, and now you're ready to build the 3D model.
Yeah, so this is actually one of the longer steps, this building part here. And this is all GemPy under the hood.
Yeah.
It's using like Gaussian processes to determine like, you know, fits to planes and things like that. But
Yeah.
hopefully if we wait a little moment.
At this
Okay, so
point,
now
you
it's
might as
rendering.
well be on Python or on 3D
Yes,
Studio. Yes.
yes, exactly, exactly. So, you know, this whole workflow has a REST API. So we could be like pulling this out into like different projects as well.
Yeah.
Yeah. And so
Well,
here
there
we
we
go.
go.
Yeah. And so
Amazing.
I've played with this a couple of times, and this is actually like generally kind of good, like pretty truthful to what Bingham Canyon does look like. You do have these inclined beds like this that are very slightly curved and tilted. You do have these layers on the top here. So even though this is, like as you said, vibe coded geology, there is a sort of reflection of the truth here.
Did you have in this specific document images in it
Hmm.
that allow
Yeah.
you to compare the output to the images?
It sort of uses those images in the summarization and the consolidation of text here. And it'll also pick out sort of values of things like dip angles from the text, and that'll be stored in a bit of metadata here as well.
I was going to ask specifically about deep angle as an example, because if you didn't have in the text the deep angle and you
Hmm.
had just a flat image
Yep.
with, you know, an horizon at an angle, it
Hmm.
won't be able to do a calculation on the spot from the image, so the image wouldn't help,
Hmm.
right? So
Yeah, you're
yeah,
completely right there. So what GemPy would do in that case is that it wouldn't have that conditioning point to put a dip there, so it would be unconstrained.
yeah. So in this case, having the image is a good QC step.
Yeah.
Um,
Should we have a look at the source
yes,
document and see if we can compare it?
that's it.
Yeah. So yeah, no, we're looking at this document here about Bingham Canyon. So let's go down, try and find some images here. I think there's some better ones later on. I think maybe it was just this one here. But you have these sort of like canyons here. You have the intrusions here that are indicated here. And then let me just try and find, there are like locations in this document where it's like indicating dip angles and things like that.
Yeah,
Maybe this one isn't the best one to look at, but you know, I've sort of compared this with other ones in the past, and
yeah,
it's
and
it's
yeah.
not too bad.
No, we get the gist of it. That's all good. Just curious, I mean, for the audience who isn't aware of how this image processing works, could you give us a bit of a look as to how OCR translates an image like the one we're looking at and turns that into whatever ends up being stored in the
Yeah.
data set?
So how I do this is I run text extraction from the PDF, and that's just the text,
Yeah,
and then extract out the embedded images as well. And then because Llama 4 is actually a like a multimodal LLM, you can actually feed it in directly as tokens there, and then it will understand actually how to, you know, how to understand what is in that image, and then it can make text output based on that image, and it can say things like, oh, you know, where would a you know, where would a bed be, where would a fault be, and things like that. So
okay,
it's
so you're
actually
leveraging the
incredibly
vision
easy.
models. That's the vision model capability there.
Yeah,
So
yeah.
so
but
you
but
didn't need to do the OCR prior.
Well, so the vision model is only for the images here, and
Yeah,
each image will have like a separate one.
right.
Whereas, like, I think in the future, I want to do vision models for the entire pages.
Yeah, right.
You know, I'm very open for external contributions. So if you want to, you know, add one of those capabilities that we talked about today, I'm more than happy to take that on.
Fantastic. Do you have any sort of documentation as to what is it that the source document is required to contain to be able to generate this 3D model? Because you need, horizon names, and you need parameters,
Yeah.
depth and deep angles, everything that we're talking about. But is that documented somehow somewhere?
Yeah, so I believe, yeah, there's a README for this. Maybe I can just, so here's the page
Yeah,
for the code base. Yeah, so I think I mentioned that you know, it needs to
lithology. Yeah,
have information about lithology, structural interpretations. I mean, these can just be interpretations. They don't have to be hard numbers,
yeah,
and it can take out whatever knowledge it likes. Cross-cutting relations is a really important part for the DSL generation, determining when events happened. And then also it does have the capabilities of taking out relative and absolute time orderings to generate that DSL.
yeah,
So in any information like this that's in the text will be particularly extracted.
yeah. Yeah, I presume there might need to be some kind of translation, so to speak, between what you have done. This is in the mineral resources domain
Mhm.
to oil and gas workflows and what
Yeah.
typically is entailed in a reservoir modeling workflow for our
Yes. Yes.
geoscientists in our industry. But the gist of it is there, and I'm sure people can figure out what is needed and how this could be tailored
Yes, that's a really great
to
point.
more
Yeah.
oil and gas related geoscience workflows
Yes.
and reservoir
Yes.
modeling. Fantastic, very exciting. Yeah, I'm gonna have a play myself with this stuff
Yeah.
soon,
Of
and
course. Let me know how it goes.
yeah, absolutely, and we'll be in touch, man. I appreciate your time, William. Thank you for coming on and showing us this, and let's be in touch, mate.
Awesome. Thanks. I really enjoyed this.
All right, mate. Take care.
Okay. Goodbye.